Normally it's drive back, it's like slowly goes.
3 miles an hour.
Yep, then it's make sure you're right here and then what chapter are we on this one?
It's actually not a chapter in your book. It's something that we covered last year that we need to cover again.
Data from various sources, yes.
Everything that you see listed there is just the beginning of different types of things that we do statistical analysis on. What?
Yeah, like volleyball, Thursday.
Yeah. Anymore, our society thrives on nothing more than statistics. Okay? Even as a farmer, it amounts to how many heat days you have and how many heat units. That's statistics. What time of the year that it happens, it all involves statistics. If I'm trying to keep statistics for a game or an event that happens, it's all statistics. Okay? That's why we call them statisticians, because they're actually keeping the numbers that we are using to figure those statistics. Some data is cut and dried, just like scores from a test. It's pretty straightforward, isn't it? Okay, you get a certain number out of a certain number that you attempted. Percentage of aces, if you attempted 6 serves and 5 of them hit the floor on the other side, straightforward statistic, right? There's no what they call biasness into that. How many people like cookies and cream ice cream? Okay, that's a statistic, isn't it? Like when you raised your hand and said, I like it, that becomes a statistic then? How many people turn the doorknob on my door to open it up? That's a statistic.
You were gonna explain that.
Huh?
You were gonna explain that.
I was told not to.
Oh.
My hand is froze.
No, she was kidding.
Yeah.
Well, then towards the end I'll explain it. Okay? So do you understand that statistics can come from a lot of different places, right? It's just not a mathematical thing. It's totally everyday life that statistics measures. But some things carry with it a biasness. Do you know what a bias means? Do you know what a bias means?
Kinda like, you prefer one thing over another.
Okay. Okay, it also involves sampling. In other words, where do you get your statistics from? Similar to if I made the following question, and I sampled people. If I just ask the question, how many people like ice cream? If I ask that question in here, I can get not a random sample, but I can get an exact sample, can't I? Out of the 18 people that are in here, I can get an exact number, can't I? Right? Okay? And my statistics would generally be pretty true. It would not have any bias attached to it. But what would happen if I did that same sampling and I stood outside an ice cream store and asked how many people like ice cream as they come out of the ice cream store?
People are going to all be for it.
I have a bias sample then, don't I? Does that make sense where bias comes into it? If I stood outside a Walmart and asked, how many people like to shop at Walmart? Don't you think I'm going to have a bias sample?
Yeah, a lot of people are gonna say no.
Yeah, I was gonna say, I shop at Walmart, but I don't like it.
And then there's always uniqueness into any sample that you have. Okay? So do you understand that whenever you're doing statistics, you need to eliminate bias? Okay? Because you will have a skewed result if you're standing outside the ice cream store asking them if they like ice cream. Wouldn't you agree? If you're standing outside of Walmart asking how many people like to shop at Walmart, it may be skewed because they may all be like a couple of the people in here that don't like to shop at Walmart, but we're going to shop there anyway. You know. Okay? All right? How many people like to shop at Shopko? Not very many anymore. How many people like to shop at Target? They don't like that because they got invaded.
I really like your shirt
already
tie.
got invaded.
Yeah, thank you.
You don't care? That's kind of not needed.
What?
Like a lot of people started to shop at Walmart, that's why no one likes Walmart.
I love them.
So do you understand what bias is? Sampling techniques.
Credit card fees.
If you're talking about sampling techniques, if I am standing out in front of the ice cream store, I am going to not get a random sample. Would you agree? That means everybody that comes out, I'm canvassing or asking everybody that comes out of the store. It's not a random sample. Okay? What do we mean by a random sample?
If you stand outside the ice cream store and ask if they like pizza.
Okay? That would be, but if you're asking everybody that comes out of the store, are you doing a random sample?
No.
Okay? Random sample means that you are not taking everyone, you are taking a select group and then projecting over the entire population.
Like how they say 1 out of 10 people do this.
Yes. Okay? Just, where would I get a random sample in here that would not contain any bias, but it would just be a random sample?
Every other row?
Yep, every other row or every other chair. That would be a random sample. Correct? Doesn't have any biasness in it, because I would start, like, say, with Andy, and then go to Zach, and then go to Sean, and then Lane, etc. That would be every other chair. Does that mean I get an opinion from everybody?
No.
No, I'm getting a random sample. Okay, that's unbiased. That's what they do when your moms and dads, or probably you even get them, You get telephone calls that say, "We are taking a survey," and you have been chosen. That means somehow they have randomly chosen your particular either phone number or by your name or whatever to participate in their survey. Do you think they are calling everybody in the United States?
No.
No. Okay?
I think when they're gonna call it, ask about like ice cream. What, doing it for that,
You want me to call you tonight to ask you about ice cream?
No.
No. Okay. I don't want to either because that's a long distance phone call.
we don't have a phone here.
You don't have a phone?
Home phone.
No. I'm sorry. Okay. Do you understand random samples? What if I wanted to get a large population, say in the city of Omaha, and I wanted to ask a very diverse group of people? I would probably go to the phone book and then just start randomly selecting them, like every third name, every fifth name, or something like that. That would be a random sample.
Every other building.
Every what?
Every other building.
Okay.
That's still a lot of people.
But that may not be so random because one building may have a lot of people in it because it's a big business, and the next one may only have a few. So you kinda have to be careful there. You may be skewing your information. Does that make sense? Okay? So whenever you're sampling, if you want unbiasedness, you have to make sure that you cover all the bases without having a select group being involved. Like you said, every other building, what if one building has 100 people in it, the next one has 5? Okay? What if you go into a ghetto or slum area in a major city as compared to the suburbs? Do you think you're gonna have some biasness on your survey? Of course. If you are going to talk about, say, salaries or something like that, or incomes, generally the people in the suburbs are gonna have higher salaries than those that are in the inner city. Okay, generally speaking. Okay? Does all that make sense? We are going to talk about counting principle. And we're not talking about the principal that sits in his office or her office and counts how many times that you have been there serving detention. Okay? Counting principle.
This is the principal's LED. Yeah, I got you.
Okay?
Yeah, I can for that.
The counting principle is how many items can be selected. Okay? So counting principle. That means if I had 2 shirts, 3 slacks, 2 pair of shoes. How many different outfits could you come up with 2 shirts, 3 slacks, 2 pair of shoes?
Alright, we can settle.
Huh?
Well,
You remember this,
no, I do.
okay?
I always found that's like the funnest thing to do.
Okay, so to come up with the counting principle, if you had this idea, you multiply all the different things together, you would have 12. Can you draw me a diagram of it? In other words, you would have like,
2 shirts, slack.
this would be your green shirt, this would be your black shirt. From that green shirt and the black shirt, you could have your black slacks,
Oh, yeah.
your blue ones,
Oh, yeah.
White.
or your, how do you spell khaki?
K-H-A-K-I.
Good job,
Yeah, K-I.
And so down here, you would have your black,
Black and black.
your blue,
Black and blue.
and your khaki, right? Which you can't see, right? And with each one of these, don't you have your tennies
Yay. And that
and your dress, right? Tennis shoes or dress. Of course, you all know what tennis shoes are, don't you? Sneakers.
Oh, you should've done boots.
You just seriously don't know what to do?
No.
I saw that commercial the other day, I think it was starting to
You guys, that were tennis shoes every day.
It's weird how we call them tennis shoes. I don't wear them.
I've never played.
I've never.
I played.
Look at you, on the wing.
I don't even have one.
So you have all the combinations, right? And you count up the last ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Very simple on the counting principle.